Hello, my name is Denis Pynkin, and in this talk I will try to briefly describe the OSTree project itself and some internals from local administrator's perspective. With the help of Apertis OS taken as example, I will demonstrate how to use reference command line tools for management operation system based on OSTree. If we try to compare the most widespread methods of updates, they are different for Linux platforms. I'm sure this is not a news for you, and our methods demand a different amount of network traffic and storage usage, especially if we are talking about storage capacity and disk wearing. So the most used upgrade method in the world with the full package change requires the moderate network and disk capacity, but doesn't allow to do rollbacks. This approach is used by Android, Debian, Ubuntu and other systems. Slight modernization of full package upgrades used by RPM-based systems, for example by Red Hat's use, this is RPM deltas, and differs from the former method only in lower network consumption. The easiest way to create upgrades is to reflash the whole disk or partition. This approach is often used by default for embedded products, allowing to do rollbacks in case if something goes wrong but have the highest effect to network and storage. OSTree-based systems use the git-like approach, so update contains only binary diffs between system states. It also has built-in support for rollbacks with very limited dependencies. So, what is OSTree? First of all, it is now called libostree officially, however the old name is still valid but shorter. The project created for GNOME CI allowing to do numerous upgrades and rollbacks with minimal efforts, and consists of library itself with a reference CLI tool named OSTree, allowing to manage the OSTree-based system. Also, there is an integrated support of different bootloaders. Some high-level OSTree features which makes our life easier. It provides more or less stable and reliable library with bindings to most of programming languages. Stores multiple operation systems and variants in a single repository. Operates at the Unix file system layer, which means it supports any file system or block storage layout, including flash devices, and no need extra partitions to implement resilient upgrades. This simplifies partitioning and boot process and saves a lot of space. Read-only stateless root file system brings atomicity and no risk of inconsistencies for operation systems. We can use literally single system call for switching between the operation system versions. Also, we use git-like model, which means we use the single object repository, and updates over the network are very effective. Deduplication is done on file system level, meaning it stores a single copy of each file used in operation system. It is done via SHA sum hashes and hard links. OSTree provides secure and reliable updates and rollbacks. Rollbacks are absolutely the same as upgrade from libostree perspective, and we should care about only several directories like var or etc and application data as well. OSTree is distribution friendly for updates via distributed network with multiple updates sources including peer-to-peer. Minimization of network consumption is a side effect of git-like model, since we download and store only file objects absent on local storage. It is also possible to use mass storage devices for updates, however that needs some support from operation system itself. It is possible to use OSTree for applications distribution. For instance, Flatpak and RPM OSTree projects use the same approach for their applications. The local OSTree repository could be used by applications as well to achieve benefits from deduplications. For example, Endless OS use that approach. Local object-oriented storage is the heart of OSTree model. Repository contain 3 basic object types. Commit describing the state of stored root file system, metadata and hash ID of the root. Commit could be signed due to security reasons, and commit is the main foundation for version to upgrade or rollback. Dir-tree files contain file objects lists and their metadata like ownership, permissions, attributes, and so on inside of directories, and file objects themselves. Each object can have detached metadata in addition. Okay, let's check how OSTree repository looks on the real system. If we list a content of directory OSTree, we will see 3 additional directories. Repo, containing all file objects for repository and configuration of repository. Deploy, containing deployments which is extracted root file systems. And boot, special boot directory, and symlink showing which deployment we use for current boot. Directory repo contain additional directories. The most interesting is objects directory, which contain all objects we are talking about. Refs directory, which contain branches, branch names, remote branch names, and hash ID commits for these branches. And configuration of repository. Configuration file is pretty simple. It's just a text file with description of repository itself and per remote configuration. Each remote must have URL and probably additional fields like here we have GPG verify, sign verify, and collection ID. The next interesting directory is deploy. On the first level, it contains operation system name. So each operation system have its own structure, like deployments and var directory, which is dedicated for single operation system and shared among all deployments. Let's see a simplified overview of OSTree internals to give an idea how it works under the hood. We need support from initramfs, which should to construct the bootable root file system by using bind mounts. We use hard link trees to position files inside of the root OS, and only ATC and var directory are treated differently. ATC is dedicated per deploy, and we use a three-way merge when we do an upgrade of the system. var directory is single for operation system, like Apertis in our case, so we have to care about files inside of this directory during upgrade and rollback. User directory is always mounted as read-only. OSTree is suitable for merged USR. In our case, you need to use additional bind mounts. Also, unlock feature is working only with USR directory. Integration with bootloader is one of key features of libostree and handled individually for each bootloader type. Boot configuration is prepared during OSTree upgrade process in a separate full loader tree, so have no any effect to already booted system. The atomic switch itself the last step during upgrade and setup of bootloader's configuration. The kernel init-ramfs kernel parameters are defined in bootloader's config, as well as deployment ID to use for rootfs. If we check kernel command line, we will see special option named OSTree, which point to a full path of bootable deployment. Okay, now it's time to try some basic CLI commands. OSTree CLI is a single binary which contains a lot of built-in commands. The full list of commands for the installed OSTree version could be shown with ---- help option. OSTree version shows you not only the version of installed libostree and OSTree CLI, but also shows you some additional features which are compiled in during a build time. The most of administration tasks should be done with OSTree admin command. For instance, it could show you current deployment, which is used for creation of rootfs. It also contains the most useful command named OSTree admin status, which shows you the current status of your system. It shows at least which deployment is used for booting, and shows the reference where this commit ID comes from. For example, in this case, this is origin and minimal version of Apertis. In our case, origin is the name of the remote, and we can check the list of used remotes with the command OSTree remote list. For now, for sure, we have only origin. We can achieve URL of origin via several commands like OSTree remote subcommand, or directly taken from configuration file, as you see on list. So, how we do an upgrade? There is a command named OSTree admin upgrade for this task. Let's do a live upgrade of installed system. But before the upgrade, I want to check the free space on the partition with repository and deployments. As you see, it is available 1.3 GB of free space. Let's do an upgrade. OSTree admin upgrade command do 3 tasks. First of all, it connects to server and download binary diffs between current operation system state and last available from the server. So as you see, it downloads only 76 megabytes. The second task is to deploy the new deployment based on this commit. And the third is to prepare boot configuration for the new deployment. If we check OSTree admin status, we will see that for now we have 2 available deployments. The initial one with a star here, and a fresh deployment which is have state pending, and we will switch to it just after the reboot. OSTree admin status shows a bit different situation after reboot. Now we see that we are booting in new deployment, and the initial one have status rollback, so we can switch it to it if we need. And we see that disk usage is not so big, only a bit more than 100 megabytes used per new deployment, 70 megabytes for binary updates, and some disk space for technical needs and ATC directory. Now I will try to collect some useful information about the current operation system and deployment state. The first command OSTree-refs will show you all local references which are known for our local system. And with the command OSTree-ref parse, we can get hash ID of commit used by that reference. Just to show you how all commits are placed in repository, I will start find, and as you see we have two commits here for initial and upgraded commits, and additional files named commit meta, which is detached metadata for that commits. The next command OSTree show shows you the commit metadata, like with useful information like commit ID, date of preparation, some text field, I don't care, but it shows not all available metadata. There is additional option named row which show you the complete data, and as you see here we have additional interesting information like binding to branch, OSTree collection, the name of collection, and some additional information. Also, we can check changes in the ATC configuration in comparison with configuration inlined into the commit itself. This is command OSTree admin config diff, which shows which files were modified, like fstab, machine ID, and which file is created from scratch. For example, resolve-conf. Probably it would show which files were deleted and so on. Since the repository with all available information is located on the single partition, it is vulnerable to disk failures or underlying file system corruption. It's crazy, right? In case if something wrong happened, we have to restore the repository but only after successful restoring of bottom layers. There is OSTree check command which could help with that task. For sure, on my fresh installation it shows nothing. It's okay. But now I will take some file, I do not know which file actually, and do something strange with it. I just emulate the problem in repository. After that I will start fsgk again. It takes a long time. As you see, fsgk command found some corrupted file object, and both available commits use that file, so they both are marked as partial. Hopefully it is very easy to restore the corruption. We just need to pull from origin the last available commit, and as you see we download two metadata and one content object, which is exactly our file which I corrupted before. The second problem is outdated and unneeded commits and binaries from previous installations. We have to do some repository cleanup. By default, prune will not clean up my test system since it is too fresh and have not a lot of commits, but we'll see. As you see, if I start OSTree prune on my system, it do nothing. So that leads us to a different task: how to undeploy the unneeded deployment. If we check the current status, we will see what we have: deployment which we are booted in, and rollback, the initial deployment which we are not using for now. And references shows that we have two bootable configurations. To remove unneeded configuration, we have to use command OSTree admin undeploy and use the ID of deployment started from 0. So we have to remove the first one. Remove it boot configuration, and after that we will have only one deployment. Sometimes it is needed to fix the library or binary on read-only USR due to security or compatibility reasons. Usually we have to reboot to apply the changes, but if that's not possible for any reason, we could use hotfix built-in mechanism. This could be done with OSTree admin unlock command, which mount overlay fs on top of user directory, allowing to change the contents until the reboot. And OSTree admin status will show that we have unlocked deployment. Sometimes it is needed to check the history, for example, to check which changes are in this commit, or when this commit was built, and other information. Unfortunately, the OSTree log command shows only locally available history. So that's why it shows only the single commit in my history. But the history is available on the server side, so we have to download it. Usually it is downloaded by pull command, but with all binary diffs, which is huge overhead and could be impossible for embedded systems. So here we pull only commit metadata. We've selected depth only one, or for example 5 steps, to have that part in the history on the local side. So if we try to check log after that, we see a lot of entries starting from ancient history. The information from the log could be used for operation system rollback or downgrade to any commit available on the server side. As I mentioned at the beginning, the rollback and downgrade process is absolutely the same as upgrade process. So OSTree upgrade admin upgrade command could be used for rollback or downgrading to previous version. Just need to add additional commands, options like allow downgrade and override commit in my case. I took the first available commit, which is downloaded pretty fast, and deployed just like ordinary available upgrade. Let's wait and check OSTree admin status. Ta-da! After the boot, we see that we are booted into downgraded version, and we still have a previous version which is marked as rollback. So that's it what I want to say about basic usage of OSTree CLI. Thank you and goodbye.